A packed room at MIT, two professors standing at a chalkboard. One of them clutches his chest and, theatrically, drops to his knees, beaten. What can you possibly write on a chalkboard that makes another mathematician collapse? This is the story of the biggest number anyone has ever named. The interesting part isn't that it's big, it's how it was built. To build it, one of these two men had to leave ordinary arithmetic behind completely. And it all came out of a game you have almost certainly played yourself. You know this game. You say a big number, your friend says a bigger one. You go higher, they go higher, and then someone shouts infinity. Someone else shouts infinity plus 1, and the whole thing dissolves into giggles because everyone knows it just goes on forever. Well, in January 2007, two philosophers sat down and played that game for real, as an actual duel, on a chalkboard in front of a crowd. Agustín Rayo from MIT against Elga from Princeton. Old friends as it happens. And they leaned all the way into it. The whole thing was staged like a prize fight, ring names and all. Rayo fought as the Mexican multiplier, Elga as Dr. Evil. Now, you might be wondering how this is even a contest, because the playground version has a cheat code. Whatever number your opponent writes, you just write that plus 1. You win every round forever, which means nobody really wins. The game's broken before it even starts. The two of them agreed on some rules first to shut that loophole. Finite numbers only, no sneaking infinity into the room. And the big one, you're not allowed to talk about the other player's number. No, their number plus 1. You couldn't even use words like names or refers to. Every entry had to be a real number, built honestly, from scratch. That detail changes everything. Once you can't piggyback on the previous move, every new number has to stand on its own mathematical structure. The duel stops being a reflex and becomes an actual demonstration of mathematical power. And once you take the cheat code away, this silly playground game turns into something else entirely, a test of who actually understands mathematics more deeply.
It starts gently. Elga goes first. He writes a 1. Just 1. Rayo answers him. He fills a long row of 1s, stretching right across the board. So Elga strolls back up to the board and, with one flick of the eraser underneath them, turns every single one of Rayo's 1s into a factorial, and then a factorial of a factorial, stacked on itself. The room laughs. It's low-tech and it's brutal. At first, this is still ordinary arithmetic. Rayo uses space to make numbers bigger. Elga uses notation to compress that space into explosive growth. A factorial already turns manageable numbers into monsters. Stack factorials on top of factorials, and the chalkboard starts looking less like arithmetic and more like scaffolding. Then the category changes. Rayo writes something tiny and calm, the Busy Beaver of a googol. A googol is 10 to the 100th power, a 1 with 100 zeros trailing after it. But Busy Beaver is not a calculation. It asks a stranger question. Take every tiny computer program of a given size. Some eventually stop, some run forever. Among the ones that halt, which survives the longest before stopping? Count its steps. That maximum is the Busy Beaver number. And if you could calculate Busy Beaver exactly, you could solve the halting problem itself. So this function eventually outruns every ordinary computable recipe for generating numbers. Exponentials, Graham's number, tree of 3, all eventually left behind. Elga answers by changing the rules again. He draws a black box, a machine that can instantly answer halting questions, an oracle. With that impossible button added, he defines a stronger Busy Beaver. So Rayo built a machine that can solve the halting problem for Elga's machine. Then Elga climbs again. Every rung solves the impossible questions of the rung below. The chalkboard fills with primes, superscripts, oracle labels, dense towers of notation. The duel was never really about arithmetic size. It was about changing what computation is allowed to do.
But here's the thing about that tower. You could climb it forever. Every move is still the same kind of move. A faster function, a stronger machine.
So Rayo changes the game. He writes one sentence, the smallest number larger than every number definable in formal mathematics using at most a googol symbols. That works because with a fixed language and a fixed symbol limit, there are only finitely many possible definitions. His number is simply 1 past all of them.
Think about what's actually on that chalkboard. Those marks are not giant numbers written out digit by digit. They're short descriptions, a few symbols standing in for values so large no one could ever physically expand them. Every move in the duel fits that pattern. The factorial chains, Busy Beaver of a googol, Graham's number, tree of 3. Each one can be described in far fewer than a googol symbols, so every one belongs on the same list, all numbers describable within that symbol limit. And because the limit is finite, the list itself is finite. There are only so many possible descriptions. That means the list has a top entry. Rayo's number is defined as one more than that. That's the shift. Elga kept inventing stronger constructions inside the game. Rayo stepped outside it. Instead of building another huge number, he referred to the entire space of possible descriptions at once, then moved past all of them in a single line.
Now, this should bother you because it sounds exactly like the cheat code they banned. The biggest number anyone can name, and then bigger. It sounds illegal because there's an old trap sitting right here waiting. It's called the Berry paradox. Try this phrase on for size. The smallest number that can't be described in under 20 syllables. Except that phrase just described it, in under 20 syllables. The sentence folds back onto itself. That's the danger. A language talking about its own descriptions from inside itself. And Rayo's move sounds almost identical. Take every number definable with a limited number of symbols, then go one bigger. So why doesn't the whole thing collapse? Because Rayo never used the loose everyday word describe. He fixed a precise formal language with fixed symbols and fixed rules. On the lower part of the chalkboard are the allowed formulas themselves, short formulas, countable formulas, mathematical objects. But then another problem appears. How do you know a formula actually defines a number? Now you need meaning, truth. You need to ask whether a formula is satisfied. And this is where Alfred Tarski enters the story. Tarski proved that a language strong enough for arithmetic cannot fully define its own truth from inside itself. If you try, self-reference comes roaring back and the paradoxes return. So you step upward. One language writes the formulas. A stronger language talks about those formulas from above. That arrow between the two chalkboard bands is the entire trick. Rayo did not smuggle in an illegal bigger number from inside the game. He changed levels. He climbed above the language the numbers were written in.
And this is where the floor quietly gives way beneath you. Up to now, the duel still feels physical. Elga fills the chalkboard with giant constructions. Agustín answers with denser notation, tighter definitions, shorter expressions that somehow reach farther. The numbers climb upward like towers. But Rayo's move is different. It is not just a bigger number. It is a rule about descriptions. Fix a language, fix a symbol limit, say a googol symbols. Then gather every number that can be uniquely described within those rules. There can only be finitely many such descriptions, so there must be a largest number among them. Rayo's move is simple and devastating. Take that entire collection and go one beyond it. Because Rayo's number isn't a fixed landmark. It's not a mountain that's simply a certain height. It depends completely on two arbitrary choices, which language you're allowed to use and how many symbols you're given. Both of those are just dials, and if you turn them, if you hand yourself a more powerful language, you can pull the exact same trick one level higher and name a number that makes Rayo's look tiny. And people did exactly that. They reached for richer and richer languages, and every time out popped a new biggest number, bigger than the last one. The chase never actually ended. It just moved up a floor. And here's the part that really gets me. How big Rayo's number even is depends on which axioms of mathematics you take to be true, and mathematicians genuinely don't all agree on those. So the biggest number anyone has ever named doesn't even have one settled size. Its value is tangled up with questions about the foundations of mathematics that nobody has closed. So the frontier of enormous numbers was never really about arithmetic at all. It was about language, about how much you're allowed to say. So is there a biggest number you can describe? No, but not because the numbers ever run out, because language doesn't. There's always a more powerful way to speak, waiting just past whatever edge you thought you'd reached. It only gets bigger and stranger from here. Subscribe and like so you don't miss what's coming.